Hope everybody's still awake. I promise this is going to be the last talk. Right, so Internet of Cats. Let's get started. Cat person's hands up. All right, dog person's hands up. You know what? Most of what I'm going to be talking about is applicable to dogs as well. In fact, if you have gerbils, it's perfectly fine for that as well. So, starts with me. Name, pronunciation, von Csefalvay. I'm the CTO of Helioserv. We are a data science consultancy per se. We provide data science services to enterprises large and small, mainly more on the large side, and generally fairly unconventional solutions. I've had a past in corporate big data roles, and before corporate big data roles, I had a past in geospatial intelligence analysis, and before that, I was a commercial lawyer for my sins. I'm all better now. So that's me. Then the cat, whose picture is for some reason missing. My cat is called River. She's been with us for about 3 years now. She's very adorable. She, unfortunately, as I said, the picture is missing. Little tortoiseshell kitten, but yeah, big. And so about 2 years ago, my cat started having various issues with basically kidney infections, kidney stones, that sort of nonsense. You have a cat, you know that the average vet bill for one of those things can actually knock things out of the park pretty badly. So I decided to do what every completely insane person with some technical education does, which is basically surround this poor animal with as many sensors as I humanly can, creep on it 24/7, and then put machine learning mechanisms on top of it, and then go around the world talking about it. So you can't go creepier than that. And that basically ended up with FATCAT, the feline assessment topology for care and automated treatment. That's a backronym, by the way. I had FATCAT the name before I had the outcome. So it actually is now expanded to 600 distinct sensors. They're connected over an MQTT backbone. The whole thing runs on commercially available off-the-shelf sensors, commercially available off-the-shelf computers. It outputs to a dashboard, outputs to a pure data archive, and outputs to EMR for data crunching. And the whole cost so far has been about basically under $500, roughly. So roughly the same in euros. I don't know what it is in non-real currencies. So this ends up with a topology that looks a bit like this. Now, unfortunately, this is not as visible as I was hoping for it to be. So let me see if I can actually explain this chart a little bit. So what you see here essentially is a fairly conventional topology that you will see this all around IoT. There are individual sensor acquisition points, right? These ones, they all have names like scanner living room, or there's one that's her little living space, the kitten, like a kitten box. Each of those units looks like this. It's a Raspberry Pi in a box, comes with a DuPont cable on top of it, and then that connects to a couple of sensors. This is an MCP9808, that's a temperature and humidity sensor. Normally, you got sensors pairwise, so the same thing is measured by two sensors, and there's various voting mechanisms to make sure that if suddenly one of the sensors says that the air is boiling around your cat, that's probably not going to set off an alarm. What happens with the data? Data goes to the bridge server. The bridge server decides what to do with it. Bit of it goes to, I don't know if you can read Amazon acronyms or Amazon figures, but the left side on top, the red, is S3, which is the simple data bucket storage. And underneath that, everything older than 90 days goes into Glacier, which is a long-term, very cheap storage by Amazon. And quite simply, what you do with that is the data goes in there and stays there, basically. That's for data that you want to keep for forever, basically. The rest goes into a relational database, and underneath that, for particular things goes into Amazon Elastic MapReduce, which is basically Amazon Hadoop. There's a connection to Twilio, which basically means that if there's something really out of the ordinary, I get a buzz text message in the beginning that was so intensely false positive that I got woken up every 20 minutes by ring, 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 alert, something's wrong with your cat. Now it's so good that we can spot particular things way sooner. We have managed to do some fairly interesting pattern extraction on how, and I'm not going to go into the dirty parts because there's urine and all sorts of other stuff involved, but how do you see your cat sick? He eats less, etc., etc. Spotting that about 3 days less cuts the weight bill in half. That's roughly the mathematics behind it, and that's about as much math as you'll have in this whole talk. So capabilities, real-time location, food and water intake monitoring, UA levels, temperature, behavior, or sleep cycle, which you might wonder, okay, so what's the whole point of this nonsense? Why is somebody here at a proper nice venue and talking to proper nice people about cats, especially if they're not necessarily cat people? Well, the idea is that a lot of this has very little to do with cats and a lot to do with how the Internet of Things looks and works at the moment and where it is going. Well, there are 3 things to deduce about the fact that somebody was crazy enough to build this. Number one, there are now fairly complex systems that in their complexity rival or exceed industrial installations, and they're run by crazy private people like yourself. The second one is these systems will increasingly become enmeshed with our lives. Some of them already have. I don't know if anybody has these Amazon Dash buttons, which are very fun. They're absolutely totally useless. There's no sensible use for why anybody would need one, but they're so fun. Basically, they're little buttons. You can stick them on your washing machine, and if you're out of washing powder, you press it. It's connected to your Wi-Fi router and your Amazon account, and it orders your washing powder automatically. Fantastic. As I said, complete nonsense, but fantastic. I'll be coming to talk about fantastic nonsense in a second. And of course, the third point is that the potential in IoT is almost as big as the risk. So, and there are plenty of risks, and I don't think there's, and as I'll be talking about it a little bit, I don't think that until last week at least, much of the world understood what the risks in IoT are going to be. So what does this whole thing mean for us? Everybody here has something to do with data. You might be a data scientist, data nerd, data exploiter, data commercializer, data journalist, data anything. So what does this whole thing mean for you? 4, which are going to be, by the way, only 3 precepts. I forgot to amend that slide, my apologies. The number 1 is we need to have a better understanding of where our data comes from. Now, a lot of people in data science today come from the old statistical dogma of data is data is data is data, right? It doesn't matter what kind of data is or what's so special about the data. The same mathematics applies to all kinds of data. The same rules that you use for time series, it doesn't matter if it's the dead at the sum or somebody's temperature, it'll work. That's not going to be the case for the Internet of Things, and nobody should even try to think about it. Data science will become increasingly contextual to the Internet of Things. You have to, as data scientists, I think, venture a lot outside your own terrain, just as I had to experience on my skin when I did commercial data science, that I had to learn up on quite a lot of things. A lot of them were things like electronics, for instance. How is that data gathered? How do these sensors work? What are these weird squiggly numbers in these sensor designation? Well, my favorite example that I keep telling people has to do with these 2 sensors. They're generally presented as interchangeable to the point that if one's out of stock, the other isn't. Well, it so turns out that the 2 of them have a rather interesting property, which is for the same temperature fluctuation, they give you different results. That's because their hysteresis is different. They maintain a past value longer One maintains the past value longer than the other. If you don't know this and put data from the two without adjustment into a machine learning algorithm, you're facing the pain of your lifetime. It's horrific. It's gonna beat you down, and you're gonna be crying at the end of the day. Speaking from experience here. So that's all I'm willing to say about this. Number two, we need to see a little more in IoT than a ubiquitous source of data. You know, when the Internet of Things came up, a lot of data scientists were, hooray, data, hooray, hooray, hooray. Well, it's not that simple. It's not that simple. And what I keep telling people is, we can do this, doesn't mean we should do this, right? There's a favorite Twitter account of mine called Internet of Shit. If you go there, you will see plenty of things that are amazing examples of things that never should have been done, right? Probably the best recently was Bill Gates' project to give kids an electronic governing skill and response band to assess what their levels of arousal during classes are. Because from that you are supposed to somehow infer how engaged they are. Really, again, all I'm willing to say about that. So common sense is a good idea. Let's put an IP stack on it is not a business or a product strategy. If something is a failing product, putting an IP stack on it will not work. It will make it just more ridiculous, and it will make you end up on Internet of Shit, and then people will be unhappy. Why? Because you're going to attract a lot of risks. There's going to be legal risks, obviously. IoT is going to get a massive clampdown in the next few years as to how the data is being used. It's right now the Wild West. I can, from what little I know about the regulatory trends, guarantee you there's going to be a massive clampdown in the next 2 years. Social risk, you can very easily get the reputation as a massive creep and lose all your customers. See, I can play all the silly games with my cat because she's not going to protest. But your customers, unfortunately, do have the option. I mean, my cat can run away and then nobody's going to feed her. Your customers do have the option of going away to your competitors, and that's not something anybody wants here. Cost price point risk, obviously, RF emissions avoidance, which is always an issue that nobody thinks about these days. The risk of being just ridiculous, again, Internet of Beep. Annoyed cat, annoyed regulators. So there are plenty of risks in putting an IP stack on something, which is why it should probably be preceded by a little more thinking than it is these days. What does that say to the data scientists? Well, dear data scientists, don't be the excuse, okay? When somebody in a product team says, we're going to put an IP stack on something and it's going to be an IoT product now, don't let them get away with the excuse of, well, it's because the data scientists need more data. So don't be that guy, as they say. Don't be that guy who justifies a silly IoT product because, frankly, most of the data gained by IoT products often is either too much to be useful, too much to be effectively communicated, or too much to be sensibly processed. So quite often, lack of thinking as to how much data do I need, what data do I need, who do I need from? Do I need it from everybody? Do I need it from, and of course the test that I always say is, would you like your kids to buy that product? Would you feel it's a little creepy if your kid bought a product that tracks them 24/7? And the third is, of course, we need to be creative about security. IoT security is going to be, it's going to be a big subject as of 2 weeks ago mainly. Up until now, there were two positions on IoT security. One was your fridge is going to kill you, and the other was your fridge is not going to kill you. It turns out it's actually a little bit more complicated. Who would have thought? So, as I said, the fear was your fridge is going to kill you, your connected car is going to blow you up, and your connected washing machine is going to ruin all your clothes. Turns out that no, but they might actually end up shutting down half the internet. Talk about epic bad timing. Here's a draft of an article I've written on using IoT appliances as botnets. Got done with it on the 10th of October, sent it off, nice abstract, etc. Analyzes the code of an IoT botnet virus called Mirai. Week and a half later, this happens. This should be familiar to most people. That was when, a couple of days ago, half the internet in the eastern seaboard of the US and then in the western seaboard of the US got shut down. How did it get shut down? Quite easily. You had the Mirai botnet code. Mirai is basically quite simple. It goes through random, it randomly dials up IP addresses, tries default passwords, so either passwords that are device defaults or passwords that would be given as the default. It's specifically targeted at the IP webcam module from a company called Shutdown. Now, if you feel like, oh, I'm safe, I didn't buy anything from that, not how it works. It's an OEM retailer, so they run under 1.5 million different trade names. So nobody knows what they have in their home, in their webcams. That should fill everybody with confidence and happiness right now. And essentially, the entire product line of this company was turned into a weaponized botnet to bring down DIN, which is the largest DNS server infrastructure. So who would have thought this like a month ago? Nobody, because the general idea about IoT risk was, once again, your fridge is going to bloody kill you. Turns out your fridge is not going to kill you, but it's going to kill the internet. And the lesson from Mirai, there are two things from it. This is the message of the user on hack forums who published the virus. One is apparently people who can't spell can write pretty decent botnets. The second is they're pretty much aware of it. People who have various malicious intents are pretty aware that that there was a move at some point over the last couple of years when a lot of devices came into our lives. They have full IP stacks. They can do anything that any other IP-enabled device can. Unfortunately, most of us don't care about them enough to actually give them proper passwords. I know this from personal experience. I have webcams in my home that don't have the default password changed. Most of us never cared about that enough, right? We thought at the very least, if our Wi-Fi networks are safe, we should be okay. Turns out that's not the case. So there is now an incredible amount of attention as to how to hack these, and the lesson is that everybody knows the IoT is badly defended. Everybody knows that security's got to be a very proactive and creative process rather than a reactive and how to respond to threats and conservative approaches. So essentially, what are the tentative bottom lines of this? To you as data scientists, to you as people who use this data, to you as also people who I would say are supposed to be driving to an extent the process of the development of the Internet of Things. The Internet of Things has from day zero been very closely enmeshed with how can we gather more data, how can we gather that amount of data more efficiently, what can we do with the data that we've gathered. Well, there are 3 lessons here, as proposed, not 4. Number 1 is the maths is maths is maths is maths, and a rows is a rows is a rows approach is not going to work anymore. So there are going to be moments when quite a lot of us will be called to venture outside our comfort zones and learn scary things like how sensors work and electronics and circuits and all that. To me, that was an absolutely frightening experience. There might be electrical engineers among you who already have most of that down pat. I personally know that it was a very new field, and we need to have an end-to-end perspective. We can't analyze data that we don't know how it was gathered, and the more we try to do that, the bigger the mess is going to be. The second one is, of course, the Internet of Things is not going to be. It's not going to fix everything. and treating it like that is just going to be ridiculous. We can connect every single cat's litter box to the internet. I can tell you, we can do that. We have the resources for it. The internet can take it. Should we? No, we shouldn't. I've built the Internet of Cats thing not because it's a good idea. I've built it because it was fun to build. And a lot of people have this correlation of just because I'm having fun building something means it's probably a good idea for consumers to have to face it. Not how it works, once again. And don't let yourself be pushed in a position of being the person who justifies idiotic IoT products. I'm not saying all IoT products are idiotic. I'm saying some are. Don't be the person who gets pushed, blah, blah, blah. And finally, of course, most of the future of the IoT is an unknown unknown. There are the known knowns, the known unknowns, and the unknown unknowns. And the unknown unknowns are the ones that tend to bite people on the back. Because we do not, at this moment, know what the next risks are going to be. We suspect, and as we have seen, we can go dramatically wrong. See, fridge is going to kill you line. And we do not know what's going to happen with the Internet of Things. It's here. It's not going to go away. We just don't know what it's going to look like in 5 to 10 years, which means this is going to be an area for the most creative in data science. And I have high hopes that the international data science community has grown so, it has produced some amazing, incredibly creative stuff, not just on the software side, but as the previous presenter has also talked a lot about the hardware side. Way more intelligence on how to deal with large data sets. So I'm quite confident that data scientists are going to be just fine, but it's going to be if you're working with the Internet of Things and if it's part of your process, we're in for a hell of a ride for the next 5 to 10 years. And it's going to be as interesting as it's going to be scary. So thank you for your attention. Any questions? Yes, gentleman in checkered shirt, please.
How did you record the urine levels of your cat?
I knew this question was going to come up. Basically, it had to do with adding a chemical to the litter, which is essentially then using chemical reaction sensors. That was the urea level. If you mean actually the urine output, that was pretty simple, litter weight. You compare litter weight as it varies over the day. That makes an allowance, obviously, for evaporation, but I really don't want to get more disgusting than that today.
So where's the intelligence in the network, so where it keeps track of, it didn't eat for X?
Sorry, I didn't hear the
Where is the state in your... so where's the intelligence in the network? So you collect observations.
Yes.
But where do you trigger, where do you keep track of thresholds and state also?
Okay. Basically, most of it is a custom application running on Heroku that pulls in resources from EMR. So that's the Hadoop data crunching part. There is then in the background, obviously, all the data is stored. And I run a set of semi-manual, semi-automated analyses on it. And that then updates the threshold values and updates various behavioral insights, so to speak.
Okay. And is your cat a happier cat after you?
I think she's a very happy and an extremely spoiled cat. So I don't know. She hasn't filed an objection yet with the FCC, so we're okay.
Thanks.
Not to my knowledge. Well, if there are no further questions, thank you very much for your attention. And yeah, thanks everyone.